We just finished the entire 7-layer reference model. Now, let's take a look at some of the statements about them in the courseware. We define a 7-layer reference model here. Everyone can see, after we define the model, an effect we can achieve as a whole. First, during our entire networking process, can reduce the overall complexity of our network. Why do you say so? Like we do a problem or solve a problem. If we divide the steps and solve them by level, relatively speaking, every step we take is simpler. If the future for a complex problem, we just stack all the questions together. So in fact, for the network communication as a whole, the development of our program and the process of future implementation is relatively difficult. So this will involve a complexity problem. No problem. After. It's the standardization that I've been talking about. When all our manufacturers are based on the same standard to production and manufacturing equipment of all the networks made in the future. Devices that need to communicate follow a complete set of standards. So in the future, whether it is product development, application development, or the overall troubleshooting process in the future, are relatively more standard. Module is a concept of our layering. Each layer is equivalent to a separate module. There is a collaborative relationship between the layers and when we fully develop each level. In fact, based on each layer, we will develop some corresponding different protocols. In the future we will learn, based on each layer in our specific provisions, or various manufacturers. We are based on Cisco. What privatized agreements does it have? These are the directions that everyone can learn in the future. That is, when we define each layer clearly, we want to achieve, make improvements to a feature at each layer, are relatively simpler. The second is the last mentioned. It is convenient for everyone to carry out a complete teaching. All right. Let's take a final look. Each layer it gives a whole process. Let's get this right. For the OSI reference model, let's first look at the physical layer. For the physical layer, what is passed between our devices is called a bit stream. It is equivalent to what we are passing is the level signal. High and low level. We specify the overall transfer rate and the transmission of our overall signal standards. This is what our physical layer accomplishes. For the data link layer, it also belongs to the physical layer. We finally put the level signal through the network port. Bits converted to 0101 binary. Then our data link layer. It is to put the binary code like 0101. Combine it into bytes. After that, we will combine them into the frames here on our second floor. Data frame. And use the MAC address of the data link layer to access the data as a whole. And an error detection function. This is what we just talked about. We finally make a conclusion. An address provided by the network layer. Logical address. You can see the difference between them. Why is the network layer called a logical address? Because for the network layer, its address is not like a MAC address. The MAC address itself has a small feature of its own. We all have IPv4 addresses on our computers. For my current device, IPv4 address is not assigned by me. But it also doesn't come with my device itself. Instead, it is automatically issued through a dynamic host configuration protocol, such as DHCP. It's called a logical address. It is modifiable. That is, people can modify this parameter. And for MAC addresses, it is also called physical address, also called network card address. This address is shipped from the factory. Each NIC is shipped from the factory. Will burn into a MAC address in the network card chip. We call it a physical address. This address uniquely identifies you. Network card to use. It can't be changed. So we call it physical address. Also put the IPv4 address. IP address is called logical address. Because this is what you can configure. Then it is called for the router to determine the path. This is the function we are talking about. Routing via routing. This is our 3-layer network layer. Further up is the transport layer. The transport layer provides connection-oriented or connectionless data transfer. What does this mean? Let's take a look. For our connection-oriented, it's the TCP we just mentioned. Connectionless is actually referred to as UDP. If we are using TCP. In fact, we will mention a concept of retransmission. Later, we will show you the transport layer. I'll show you when I talk about packaging. Then comes the session layer. Everyone can see. Overall, the concept of this communication session. You don't need to care too much. What I told you in class just now is server requests between different applications. Right. Here's what we're talking about. Respond to the concept of such a level. Just as understanding. Including presentation layer, encoding of data. Application layer. Our layer closest to the user. Overall to provide all the unrealizable functions of the lower layer. This is our 7-layer reference model. A series of functions that they implement. As we understand. The next step is to explain data encapsulation. Before talking about data encapsulation, let's take a look first. More basic concepts. Before talking about the reference model, we talked about the overall architecture of the network. So, similarly, we also put a few pictures in the courseware given by Cisco. Explain to everyone. Let's first look at this architecture. This is our network. We won't mention how to burn. This is just a means of industrialized production equipment. This has nothing to do with our communication link. Let's take a look at what is called a network. First of all, in this picture, here's a home office. Have a mobile users through the internet. So there's a headquarters here. Let me tell you, this is the headquarters. When you take the CCNA exam in the future, we'll see this scene. Alright. You will see you later in the exam. It's abbreviated as HQ. So what is this on the left? Branch office. It's a division. Also called a branch. Everyone can understand. For such a picture. In the future, everyone will maintain the network. Our more typically maintains an enterprise-class network. Pay attention to what I say. We maintain an enterprise-class network. To be honest, the very beginning of our maintenance is a set of enterprise network. But the business we are talking about doesn't have to be a company, such as what we call companies, schools, hospitals, governments, some such organizational units and institutions. It's actually called an enterprise-class network. Can you understand? Because it belongs to a set of enterprise-level network models, or what we call the campus network. Actually, it means, what is enterprise network? When talking about the overall network architecture, I mentioned the concept of a local area network. When we use the local area network in the enterprise network environment,